Hello everyone, my name is Peter Horky. I'm a scientific coordinator at the Personalized Health Informatics Group at the SAB Swiss Institute of Bioinformatics, and today I'm going to be talking about schema and data visualization. Now I'm going to be covering 4 topics today. First, I'm going to give you a short overview of the mock data and show you afterwards both how to load the SPHN ontology and the mock data into the GraphDB triple stored. Next, I'm going to give you a short overview of different types of visualization tasks and the techniques that can be used to accomplish this task. After that, I'm going to demonstrate how to explore and visualize both the ontology and data with the GraphDB. And last but not least, I'm going to give you a short glimpse of the process of querying and aggregating data for even more visualization. So let me give you a short overview of the mock data. So it's centered around the patients. For this, we have subject pseudo identifier IDs, and unfortunately, all of these patients have had an allergy episode, and they had an allergy episode to a specific substance, such as, for example, peanuts. And the substances, for these substances, we're going to be using Snowman CT to encode them. So using Snowman CT will allow us further down the road to do some nice type of inferencing. We made some simplifying assumptions for the mock data. For example, that each subject has only one allergy episode, and that in addition to an allergy episode, there is one lab result. And for encoding the lab result, we're going to be using the loin codes. So the loin codes allow us to encode such measure method test in 6 dimensions, and we can encode things such as, for example, we measure the count of the white blood cell in the blood specimen, and we used automated count. So in addition to this automated count with the code shown on this slide, we also going to include a manual count line code just to have some diversity. So that's all for now for the mock data overview. And now I'm going to switch to the GraphDB and show you how to load both the ontology and the data. So let's get started with that. Now I already went ahead and started the GraphDB. So I'm running locally the free version of GraphDB installation. So to create a repository, I'll go to Setup, Repositories, Create New Repository, and I'm gonna name the repository SPHN_demo. The only option I'm gonna change is under Inference and Validation, and I'll choose No Inference, and then click on Create. So next I need to connect to a repository, and there are 2 ways of doing this. Either go to the top right corner and choose the repository, or you can just click on this icon to connect repository. So next I'm gonna go to the import RDF and start by loading the RDF data. There are several ways one can do that. For other ways, please have a look at the links included at the end of these slides. And now I'm just going to click on the upload RDF files. And then I'm going to start by loading the SPHN ontology. Having done that, next I need to import it. So I click on import. And what I recommend is when importing ontology and data is to have a separate named graphs while doing so. So I'll leave the base IRI field empty because this can be read from the header of the file. For the target graphs, I'm gonna choose named graph, and I'm gonna give it a name, for example, https www.SPHN documentation.ch, and I'm going to add simply ontology and click on import. So I'm going to repeat this for also the minified line codes. So click on import, leave the base IRI field empty, named graph, and again give it the same name as for the ontology. So www.SPHN documentation.ch/ontology. Click on import again, and I repeat the same procedure also for the minified SNOMED codes. Now the name of the target graph can actually be chosen in quite a different way. So I'm basically just sticking to the convention of using URIs or IRIs to denote such named graphs. So having done this, next I'll start loading and afterwards importing the SPHN mock data. And I'm going to do it in quite a similar way. I'm going to use a slightly different named graph. I'm going to namely change the ontology at the end to the mock data. So this way I will have two named graphs, so we can actually check this under the Explore section in Graphs Overview, that there is now the default graph, which contains all, at least in GraphDB. Then there is a named graph for the ontology and also one for the mock data. Now there is one additional thing I recommend, namely under setup and autocomplete, and that is to build an autocomplete index. Now this will come quite handy later on when we're searching for things to visualize, or even with the autocomplete function when writing some queries. So having done that, I'm now going to switch to the slides before I move on with further functionality of the GraphDB. Now, before we continue with the GraphDB visualization, I think it's a good idea to stop for a second, take a step back, and think about the different visualization tasks and techniques used commonly to accomplish this task. So for one often needs to do some type of comparison, and for this, bar and pie chart are often employed. Another common task is to visualize hierarchies and or relationships, and there are various methods which can be used to accomplish this task. For example, there is circle packing, which can be used to visualize hierarchies by putting circles inside of circles. Then there is also the chord diagram, which can be used to produce nice visualizations of relationships. And there are also node link visualizations. Another type of common task is to visualize temporal or geographical events, and to that end, one can produce images of various types of timelines, and for geographical events, of course, also of maps. And last but not least, sometimes one needs to analyze multidimensional data, and for this, there are some even more advanced visualization techniques, such as, for example, radar and bubble charts. Now, in the next couple of minutes, I'm mainly going to focus on the visual graphs, so a type of node link visualization, and I'm going to be demonstrating this technique with the GraphDB. So let's move on to that. Now I'm going to demonstrate how to visualize and explore data and ontology with the GraphDB's built-in visual graph functionality. I'm going to skip the class hierarchy and class relationships visualization, but please refer to the included links either for the GraphDB documentation or the SPHN documentation. Now, if you remember, just a few minutes ago, we built an autocomplete index, and we can actually make use of that now. So for example, if I want to learn more about the lab results schema, I can just start typing it in this field, and the autocomplete takes care of the rest. So I'm going to select this now. And don't worry if you might feel a bit overwhelmed of the various nodes shown here. So I'll just give you a quick overview. So you can see that there is a form of color coding employed. So everything that's light green represents instances of the classes. And before I go to the rest, what is shown here, namely the schema for the lab result, I'm going to switch to a different image. But before I do that, let me explain you how the two images differ. So what I did is basically went to configure the view, and within this menu, I can select either the preferred types to show, but also to ignore. And I can do the same thing for predicates. So what I've done in preparation is I just took this image shown here and I set up the option to ignore the instances so that for the sake of the explanation, I can focus only on the schema in the beginning. So let me show that. Go to lab result and without instances. So this is the same image, but without the light green instances of the previous visualization. Now, what we can see that the lab result concept is a subclass of the SPHN concept, and that it also has an equivalent class of laboratory test findings. It also has various properties. For example, the blue encoded ones, we can learn more about them by hovering over them. We see that they are the data types properties, meaning they link instances of classes to literal values, such as date times, strings, or values. So this fits well with the has lab result analysis data. And when we click on it, the side panel occurs, which lists, for example, the RDFS label, but also the type, the RDF rank, which we don't really employ in this case, and also comment, which can be actually quite useful when exploring the ontology and the data. So I'll close this. And there's another type of property, color encoded here in yellow, which is the object property, and it links instances of classes to each other. And when we click on this one, we can also see that it represents the code of the lab test. And there's also one for the has lab result unit, linking the lab result instance with instance of the unit. Now, having learned more about the schema for the lab result, I usually find it quite useful if I have a look at one specific instance of this schema and then see what else can I learn about it. And I already prepared this, but let me show you how you can replicate it yourself. So use the naming convention where I named the lab result instances in lowercase. So I click lab result, and I'm just going to click select any one of those, and I'm going to select, for example, lab result 9. And now you can see that as expected, this is a lab result type, but you can learn that it has, for example, a lab result test code. So we can click on that. And now what one can see is that this instance of the code is actually shared between various types of instances. So all of these are different lab result instances. Now, if you remember from the initial visualization, one can set up to, for a moment, ignore these other instances, and I already prepared that. So I'm going to show it just so we can focus a bit more on the line code shown in the center. So I'm going to go to lab result instance with line code already selected, and we can see that as expected, it is of line type. And we can actually learn more in detail that it is a code for representing the automated count of leukocytes in the blood. And we can also see the various properties similar or actually represented the various length dimensions. And what I found nice that if we click on the link, we can actually copy it, paste it in the browser and visit the website and learn even more about the code it represents. This is actually quite nice. So similarly, we can learn more about the next code linked to the lab result, which is a UCON code for the lab result unit. And again, if we click on it, we'll see that it is shared among different various lab result instances. And again, I prepared a version of this image with focus on the UCON code. So I'm going to select that next. And we can see that it is a type unit, and the unit code associated with it is 10 to the power of 9 per liter. So let me now go back to the lab result instance once again. And one question which might now occur is, now how is this lab result linked to the actual allergy episode, or more specifically to the substance which caused this allergy episode to occur? And we can now simply follow the one remaining link, namely for the subject pseudo-identifier instance. And if we click on it double click on it to expand it, we actually see that there is a link between the subject pseudo-identifier ID and also an allergy episode instance. And if we click on expand it, we see there is that it is as expected of allergy episode type. And here we have the link to the substance instance. And again, if we expand this one, we can learn more about the specific codes that is used to encode this substance. And when we expand this one, we see as expected that it is shared among different instances, but also that it is a peanut code. And here we can again have a look at the link included. And this allows us, for example, to open up the Snowman CT browser, which I'm going to do next. And there we can learn even more about the specific substance and what type of hierarchy it is involved in. So having done that, I'm going to switch again to the slides before I move on to the next visualization. Now let me give you an overview of the process of querying and aggregating data for visualization, allowing you to do even more things with your data. So the first step is retrieving the data from the graph database, and this usually involves either writing a query or reusing a query you already have at hand. In the second part of this process, we want to group the retrieved data by some form of criteria. We want to apply some operation to this group data, for example, either counting the number of instances or maybe calculating the mean of the values within a group. And after that, we want to aggregate the obtained results to obtain the aggregated results in a form which can then be used for visualization. Now, if you remember from before that there are different visualization tasks and also techniques for used to accomplish this task. So the last step basically consists of selecting the proper visualization technique and assuming we have obtained the data, the aggregated data in the format which is compatible with this technique, we only need to run this and produce a nice visualization. So in the example I'm going to show you next, I already prepared a simple Sparkle query which just looks at the different types of classes available in the mock data and then counts the number of instances for these different types of classes. And in the last step, uses the built-in Google Charts functionality to produce a simple bar visualization. So let's have a look at that. Now for the last demonstration of my today's talk, I'm going to switch to the Sparkle section. Now, don't worry if you don't understand everything which happens in this code. What suffices at this point is to know that you have such a query at hand. You can just copy and paste it in this field and then click on the run to produce the results. So this is what I've done now. And I obtained data listing classes sorted according to number of instances found in the mock data. And in the next step, I want to visualize this table. So for this, I switch to the Google Chart tab and I just configure it by selecting, for example, a bar plot, which produces a nice visualization of my data. Now this is quite a simple example, but it has all the necessary parts which can be reused for even more complex examples, meaning first you need to either reuse or write a query to extract the data from the database. Then you bring it into a form which you can then use as the basis for further visualizations, which you can then configure, and you end up with a nice plot such as this one. So this concludes the practical demonstration. Now let me give you some additional information. So for further information, I included links to the GraphDB documentation on the section of loading data and also exploring data, which contains some additional nice examples for you to follow. In addition, I included a link on exploratory data analysis with triple stores within the SPHN documentation. And last but not least, I also include a link to an online course which has a nice chapter on interaction with linked data. Thank you for your attention and feel free to contact me.